Hi everyone, this is question 1 of Spring 2023 Exam 1. And this question asks specifically about line 21. And it is asking two things, which is whether casting is unnecessary and whether we should use commas rather than pluses. And so before we kind of get into the details, I'm going to first explain what casting means in case some of you guys don't know. And so what casting means is it's the conversion of one data type into another data type. And so in this case, it seems like it's trying to convert the data type of vowels into the string data type. And looking at the code, it seems like vowels is declared as an integer, and then it's doing some +1 here, which says that vowels will remain an integer until it reaches down here in line 21. And so vowels integer gets converted to string before it's added to a bunch of other strings. And then that ultimately is assigned to tally, a variable called tally, before it's being printed out. And so that is casting. That is what casting means. And then this question is asking, is casting unnecessary? And I'm going to be explaining why casting is necessary, especially when you're adding with other string types. And so I'm going to go over to my IDE and kind of show why casting is necessary. And so this is basically line 21, and then I just assigned vowels and others to just a constant integer, just zeros, right? And so basically, again, vowels will be converted to a string, and also others will be converted to a string before it's added onto the string, and then assigned to the variable of tally, and then printed out tally. And so if you run this, we get an expected output, right? So message has 0 vowels and 0 others. Pretty straightforward. Now, if we do end up removing the casting, if we don't convert vowels and others to string before adding it to other strings, we'll get an error. And the type error says exactly that, which is it can only concatenate string to string, not integer, right? So Python will not automatically convert types when you're adding it to string or whatever other type it is. And so it will not automatically know that val should be converted to a string before adding it to another string. That's why you kind of see this error right here. And so looking back at the question, if we were to only apply this, we know that this is not true. Casting is necessary by itself. However, it's also asking whether commas should be used rather than pluses. And so we still don't know yet whether if we use commas and no casting, then the code will work. So I'll kind of go over that real quick. And so I have some code below here that I put so that it's not distracting at the start. I will comment these out and then I'll comment these. So we'll kind of go over what commas do first. And so if you use commas rather than pluses, when you're assigning it to a variable, then I'll show you why it is not good. And it will work a little bit differently than the pluses. So commas do not necessarily concatenate strings. What they do is you'll see it actually creates another data type called a tuple, and then kind of groups it together. So comma does not concatenate strings like pluses do. It will make a whole new data type. Now, this might be confusing because if you actually, instead of assigning it to a variable, and if you actually just print this without assigning it to a variable and then printing the variable, and if we delete this will actually concatenate it, right? And so this is the difference between when you're using commas. This is the difference between first assigning it to a variable and then printing out the value of the variable, opposed to using the commas actually in the print statements. And so this is, I think, what the question is kind of trying to trick you with, is that there's a big difference between using commas within print and then using commas when you're assigning a bunch of strings into variables. Um, and so that's the biggest difference. And so this question asks, going back to the question, this is saying both whether casting is unnecessary and we should use commas rather than pluses. And so what we did over here is we tried no casting by itself. What we did over here is we tried commas by itself, so not casting. So what we're going to try is now both, and you will see that it does not work even when you use both. And so if we don't do casting and if we use commas, now the error will be gone because it's creating a tuple with a bunch of string and integer types, but it will not give us the right answer. It will still give us a tuple and print it out, which is not what we want, right? It actually works and without an error, unlike this example right here. And so this doesn't necessarily cause an error because it's separated by the comma. But what we wanted to do in this code was basically concatenate the strings and convert this into a string so that it's more like a sentence. It has a structure more like a sentence. But if you see this, it is just a tuple, and you will see that this will not work. So it will not work with casting by itself. It will not work with the commas by itself, and it will not work with both at the same time. And we've learned kind of how it just does not work. The suggestion does not work, and Louisa should not implement it. And so looking at the answer choices, it seems like A is the right answer choice. B says remove the casting. Python can infer that we are building a string using numbers. We've seen that this doesn't work at all. Python will not automatically convert types. Remove pluses. Python can infer that we are concatenating multiple strings together as one. This only works in the print statement, but not when you're assigning it to a variable. We saw that, and this can be disproved. And then D says replace line 21 with 22 with print. The message has vowels plus vowels and others, others. And so we know that this doesn't work. This was the example where we basically didn't cast it. And then so if you can see, this right here isn't casted, and this right here isn't casted, so it will bring the error, which says that string can only be concatenated with string. And so right answer in this example is A, and we'll see that it is correct. Hey everyone, this is question 2 of Spring 2023 Exam 1. And this question is asking whether we can replace lines 13 and 14 with this piece of code right here. And so there are kind of two things that are important in this question. The first thing is basically you got to understand what this code is doing, more specifically in this while loop right here, and most specifically in lines 13 and 14. So you got to know what is going on in this code and what this code is trying to achieve. And then the second thing that you got to know is what this piece of code is doing and the syntax for this. And so this piece of code actually has a ternary operator, something called a ternary operator. And so you got to know what that is, and then you got to know the syntax for that, which we will dive in a little bit later. But first of all, I kind of want to give an overview of what this program is doing so that we're kind of clear about what we're getting ourselves into. And so this program basically takes an input string from the user, and then it basically counts how many vowels and non-vowel characters are in that particular string. And so if we use the example of the string hello, if the input is hello in this case, for example, then basically the vowels will get the value of 2, and the others will get the value of 3 because there are 2 vowels and 3 non-vowel values in the word hello, and then it will be printed out at the end. So it will say the message has 2 vowels and 3 others. So that's what the program does. Basically, it counts the vowels, non-vowel values. Um, Kind of going into a more detailed overview for the code. As you can see, it takes in the message. In our case, it was hello. We'll use the hello example again. And then it has a bunch of declarations for a bunch of variables. The length, what length is it's the length of the message. And so using the hello example, the length will be 5 because hello has 5 characters. And then we have this while loop right here, and the while loop will run while the index is less than the length. And so we can see that the index initially has the value of 0, but we can also see that index increments by 1 at the end of every iteration of the while loop. And so what this while loop tells us is that until the index reaches the size of the length, it will keep running. So in our case, using the example of hello, until it reaches 5, index will go from 0, 1, 2, 3, 4, 5. And so basically, you can assume that this while loop runs the same number of times of the length. And so it will run 5 times for our case, since hello has 5 characters, and then the while loop runs while index is less than the length. And then so let's have a look at what is happening inside the while loop. So inside the while loop, first we get L, and basically what L is L is assigned to the character, one character from the message at a particular index. So for example, if this is the first iteration of the while loop, and so index is 0, then it will get the 0th index of the word hello and then assign it to L. What is the 0th index at hello? It's H. H is 0, and then E is 1, L is 2, and so forth. And so basically, L will hold the values of all H, E, L, L, O, right? Because index increments by 1, and the while loop runs until it reaches 5. And so you can see that L will be all the characters of the word of the message for all the iterations. And so going down in this code, basically what this if and else statement does is if L is, it seems like if it is a vowel, so A, E, I, O, or U, then it increments the vowel variable by 1. And then otherwise, it increments the others by 1. And so basically it counts while for every character, if it is a vowel, then it adds 1. If it's not, then it adds 1 to others. And so that is basically how this code works. At the end of the while loop, we'll have 2 vowels and 3 others because hello has 2 vowels, 3 others, right? And then it will print it out. So that's just an overview of what how this code works. And obviously we can focus on lines 13 and 14 right here. And so the question is, can we replace 13 and 14 with this code? That's the question. First of all, to understand if we can, we got to understand the syntax for this. And so this syntax initially might look super weird. It's called ternary operator. And so if you understand what that is, then you can skip this portion of the video. But we're going to go over what this is and how this works. And so to explain that, I will go over to the IDE and then have an initial example that is not using the ternary operator. And so we can see this is just an example code, and this has a very simple if and else statement. So temperature is assigned to 85. If temperature is greater than 80, it's hot. Hot is assigned to weather. Otherwise, cold is assigned to weather. So if we run this code, we get the expected behavior. We get hot because 85 is greater than 80, right? Now, instead of this, we can have a ternary operator handle the same logic. And so ternary operators might be kind of foreign, but it is pretty neat, and it's very easy to understand. And so it's the same example right here. Actually, let's use this temp again. And so temp is 85. And what this ternary operator basically does is it assigns hot to weather if temperature is greater than 80. Otherwise, or else, it assigns cold to weather. And so as you can see, it's a very reduced version of the if and else statement, and you don't really have to repeat weather like 2 times like this code is doing. And then you don't have to write 4 lines of code for a very simple if and else statement. Ternary operators are usually great for very simple if and else, such as this example. And so basically kind of going over the syntax one more time, it's basically result 1 if this conditional meets. Otherwise, it's result 2 being assigned to this variable. And so if we print this, we get the same result. It's hot. Maybe if temperature was like 60 or something, then we get cold, right? And so that's how kind of ternary operators work. And so going back to this example, now let's answer the question. Can lines 13, 14 be replaced with this ternary operator? And so now we're finally answering the question. Good. So let's have a look at the logic of this code. And so basically, vowels, so this will be assigned to the variable of vowels if this conditional. Now, this conditional looks to me pretty identical to line 13, which is a good sign. So first of all, the conditional is the same. So now all we have to look at is what is being assigned to the variable. We have to look at what result is going to be assigned at the variable, right? And so it seems like the first part is actually the same. So if it meets the conditional, vowels will be vowels plus 1, which looks to me the same as lines 13 and 14. So now we have reduced it down, and all we have to look at is else 0 part. So if it is not a vowel, it will assign 0 to vowels. Now, we got to kind of think about that for a little bit because it is not saying vowels plus 0. It is just saying 0 equals vowels. And so if you think about it, every time you reach a non-vowel value, it will just reset the vowels and just assign 0. So it will start from the beginning. And so, for example, if we have that hello example, it will be H, and then when it's H, others will be incremented to 1. When it's E, vowels will be incremented to 1. But as soon as we reach L, which is not a vowel, it will assign 0 to vowels, which is completely resetting the vowels counter, right? And so it's kind of forgetting about that E that we counted earlier. And so we can see a kind of flaw to this logic right here, which makes it so that we can't really replace lines 13 and 14 with this code, unfortunately. And so kind of looking at the answer choices, A says the statement is correct and we should talk about it. And so we can kind of cancel out A. We know that it's not true. B says the statement resets the vowels counter if the current letter is not a vowel. We talked about exactly like 30 seconds ago. And so B seems like the right choice. No, the statement is wrong because we need parentheses. It should be vowels equals vowels plus one if. So it's saying the L equals A or L equals E, all of this, the conditional stuff, should be surrounded with parentheses. And as you can see in the original code isn't even surrounded with parentheses. And so we don't need the parentheses because we know that the equals sign is superior to or. So this will always execute first before the or. And then D says, no, the statement should use and operator rather than or. And we know that that is not true because if we use and, that is a logical problem because L cannot be A and E at the same time, right? L is just one letter. And it can't be two things at one time. And so we can see a flaw in D as well. C is a flaw, as I talked about. And so the correct choice seems like it is B, and we can check this. And the B is the right choice. Hey everyone, this is question 3 of Spring 2023 Exam 1. And this question is basically asking whether, like question 2, whether lines 13 and 14 can be replaced with this piece of code right here. And so this question is very similar to question 2. It involves, again, it seems like the ternary operators that I talked about in question 2, and it also trying to replace the same two lines. And so all we need to do is, since we understood what the code is doing, and since we know what the syntax for ternary operators look like, we can just see and check this logic of the ternary operator and whether it makes sense to replace lines 13 and 14. And so let's have a look. And so it seems like, again, the conditional is exactly the same. So all we have to look is what is being assigned, the result that is being assigned to the variable of vowels. And so this seems, again, the logic seems good. So if this conditional, if it's a vowel, then vowel equals vowel plus 1, right? So as you can see, it looks pretty good for this part. Now we have to check whether the else part is good. So else vowels will be assigned to the variable of vowels. And so that's saying if this is not the case, vowels will be assigned to vowels, which is the same thing. It's the same variable being assigned to the same variable, which is meaning that it will do nothing to it. And is that maybe what we want? It seems like just looking at lines 13 and 14, it is what we want because we don't want else 0 like we looked at question 2 because that completely resets the vowels variable. But if we do nothing to it, just setting vowels equal to vowels, then this code should in fact work because, again, if it's not a vowel, meaning that it doesn't meet this conditional, then we should do nothing about it and we should not increment vowels. And so logically, it seems like it makes perfect sense just looking at lines 13 and 14. Lines 16 and 17, we'll disregard this because it's saying lines 13 and 14 only. And so looking at the options, it says, no, the statement resets the vowel counter if the current letter is not a vowel. So this is what happened in question 2. It was when else was 0 instead of vowels. And so, but in this case, it's not true. No, the statement is wrong because we need the parentheses. The conditional stuff should be all placed in parentheses, and we talked about that last question too. The original if statement isn't even wrapped around in parentheses, and that is because, again, the equals equals is superior to the or, so it will always happen before the or, and so we know that is not true. C, the statement should add and an operator rather than or. We know that is not true either. It was exactly from the last question again. And that is because L cannot be A and E at the same time. That is impossible because L is just the one character. It stores one character at a time. And so we know that is not true. And then, yes, the statement is perfect in every way, just like Isabella. And so I don't know about the second part, but we know this is true given that this logic is correct, and we can replace lines 13 and 14 because this logic is the same. And so let's try out and submit. And we know that this is correct. And so this is good. Hi everyone, this is question 4 of Spring 2023 Exam 1. And this question is basically asking now the overall effect of replacing lines 13 and 14. And so basically it is asking the code that we saw in question 2, so this piece of code and this piece of code, if one of the codes were to replace lines 13 and 14, how would this impact the overall functionality of this code? Not just logically seeing whether lines 13 and 14 is equivalent to one of these pieces of codes, but what this replacement does to the overall program. And so I'm gonna kind of talk about why any of these codes cannot be a replacement for the safety of the overall program. And so from question 3, we saw that this was a valid replacement for lines 13 and 14 specifically. And so I'm going to kind of paste this here. And so the reason why this cannot be a replacement for this is these two lines right here that says else for this if clause. And so this ternary operator said, and it was very similar in that basically it added vowels plus 1 if it met this conditional. And so it's saying that if it met this conditional, then it was going to perform this, which it did exactly that. Now, the biggest difference between this code and this code above is the else clause. And so basically, this doesn't have an else. And although the logic of this else statement of assigning the same vowels to vowels, which basically means that it's not incrementing the vowels and vowel stays the same, although the logic is the same, it's not the same in terms of the code, because if we see, a code cannot have two else statements at one time. And so an else statement for this is actually this, incrementing the others by 1. But the else statement for this is saying the vowels just stays the same. And so this is why we can see that the chunk of code from question 3 or question 2 cannot replace lines 13 and 14 for the safety of the program and the program running the same. And so since we kind of saw that, let's look at the answer choices. And so a syntax error in line 16 because the else statement will not have a previous if statement. And so this is true. It is saying that at line 16, the else statement at line 16 will not have an if it didn't have an if statement, right? Because the previous one already had an else, and so this will kind of be stranded alone, and it will cause an error because there's an else statement without an if statement. So this, we can see that it is true. B says an out of range error due to accessing a character index beyond the message length. And so this error does not have anything to do with the error that is caused by having two else statements. This is more saying an error for accessing an index that is outside the message length. And so this has no relation to the having the two else error. And then C says variable others will always be 0. And so that is kind of a valid statement, but this statement is assuming that the code will actually run. But as you can see, if you have two else statements, the code will actually just cause an error. And so this is not the best answer either. And then the while loop in line 9 will run forever. And so it's saying that this while loop will run forever. And this doesn't have anything to do with line 13 and 14 being replaced, because the index at the end of the day will always increment and it will reach the length at some point, unless the length of course is infinite or something, but that is not the case. And so we know that D is false too. And so the answer will be A, and let's have a check. And it is indeed correct. And so that was kind of an interesting question. And I think that this question actually kind of showed the bad design of question 3, because it's really asking whether it can, whether this can replace this code. But realistically, from the overall program perspective, it really can't. But just looking at the logic of the line 13 and 14, it could. So I think question 3 was a little bit confusing there. But yeah, that is question 4, which is A. Hey everyone, this is question 5 of Spring 2023 Exam 1. And this question is basically asking, out of the 4 answer choices, what syntax of the for loop should we use so that we can replace the while loop at line 9? And then the question also kind of adds an additional information saying that line 19 can be removed. But that is not the main point of the question. It's saying what syntax for the for loop do we use to replace 9 and logically make the program run the same. And so let's have a kind of look at all of these choices. And so the first one says for index in message. And so the message is going to be the message that we input at the start. And so if we use an example, for example, the input is hello, then the index, every time the for loop iterates, the index will be actually a character within the message. And that is not really what we want from the index, right? The index is supposed to determine how many times the loop iterates, instead of just getting the character value from the message itself. That is what the L does. What L does is gets one character from the word for every iteration. So we know that A is not true. And let's have a look at B. And so kind of looking at the answer choices, the only difference between B and C seems like B is length -1 and C is length. D seems like it's using index as the end, the second parameter for the range function. But B and C, the only difference is this -1 right here, right? And so we'll see which one is correct, or maybe D is correct, but we'll see how the logic for B and C kind of holds. So let's have a look. For index in range 0, starting from 0 to length -1. Now let's try to remember what length was again. Length variable basically holds the length of the message. So if we use the hello example again, length will be 5. Um, so B says the for index will go from 0 to length minus 1. And so basically it's saying that it will go from 0 to 4. That is what it's saying for B. 0 to 4. Now, why might it be trying to infer that we should do length minus 1? Well, that is because if we look at the hello example again, and if you know how indexing works in code, basically it starts from 0, not 1. So it starts from 0, 1, 2, 3, and 4. And so that is what B is trying to kind of suggest here, which is saying that the index should be 0, 1, 2, 3, 4, and not 5, because 5 does not exist over here, as you can see, right? And so that is what the program is suggesting. And C, in our case, then, since it's not minus 1, will go from 0 to 5. And so that's interesting. The only difference is, again, minus 1, and it will go from 0 to 4 or 0 to 5. So which one is correct? Now, just by looking at it logically and how I've explained it, it seems like B might be correct. But in this case, C is actually correct, is the correct answer. And that is because in Python, whenever there is a range, whether it's using the actual range function or whenever it's using a list range, right? So in lists you can do 0 to 5 like this, and you'll get basically the list, the variables that are stored within the list in this range. Whenever there is a range in Python, it actually doesn't consider this value. So it's everything before this value. So basically this is inclusive and this is not inclusive, or yeah, not inclusive. And that is basically how ranges work in Python. Also the list indexing, that's how it works. And so it will include everything until this point, right? And so we can see that C is actually correct, because if we do 4, it will do everything but containing the 4. So it will do hell, which is not hello. Hell is not the same. And so we can see that B is not the correct choice. And C is actually the correct choice because it will go all the way to 4 since it doesn't include 5. And so we found the right answer. But D says for index in range 0 to index. And so D is a little bit of a weird one. It's using the same variable twice. And it's also saying for index in range 0 to, and as you can see, 0 is initialized to 0. And so it's saying 0 to 0. So that is kind of a confusing one. I don't think that is correct. And then the C is the correct answer. And so let's have a look. And C is correct. Now you might be wondering, is this like a bad design, right? Why is it inclusive for the first one but like non-inclusive for the first one? And if you're curious about that, this is actually a good design because let's say if you're trying to get 0 to 5, and then you're trying to get 5 to 10 or something. Now, if you have a look at this, this is a very poor 5. If you have a look at this, right? If you have a look at this range, this will do 0, 1, 2, 3, 4, and this will do 5, 6, 7, 8, 9. And so as you can see, the non-inclusive for this one becomes useful for the inclusive for this one, right? So we can use the same values for these instead of having to kind of like do your mental math and do like maybe like 0 to 4 and then we go from 5 to like 10. That'll be kind of difficult. And so difficult, especially in cases where the numbers are not so easy, such as 0 and 5 and things like that. And so that's why it's intentionally kind of designed this way so that um, we can use the ranges from 0 to 5 and then 5 to 10. This includes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is why it's designed that way. Hey everyone, this is question 6 of Spring 2023 Exam 1. And this question is kind of similar to question 1 in that it is basically wondering whether we can replace a while loop with a for loop. And so it's trying to convert a while loop into a for loop. This question is asking whether that is possible, first of all, and if it is possible, what syntax should we use, or how do we convert this code into using a for loop? And so we'll kind of see what this program is doing first, so that we can kind of get an idea of what's going on. And so it's a function called sum divisors excluding itself, which I don't really know what that means. But it basically takes in the parameter of n, and its sum is declared to 0, I is declared to 1, and so while I is less than n, and n is passed in, right? So while I, which is initially 1, is less than n, then it will do some sort of operation, right? And then it will increment I every single time throughout the iteration of the while loop. And then if the while loop is over, then it will return sum. So, okay, we can see that this is actually probably replaceable by the for loop. And the reason why I say that is because the conditional inside the while loop is actually very, very trivial, is very, very simple. And all it's doing is it's incrementing I until it reaches the value of n, which is what a for loop is actually great at, and what for loop is actually designed for, right? And so since I starts at 1 and then it increments by 1 until it reaches n, we can do the exact same thing, probably with some combination of range, right? Doing a for loop with using the range function. And so let's have a look at the answer choices over here. And so A says, no, this while loop cannot be stated as a for loop. Now, we know that since this is a very simple logic while loop, for loop, it could be converted as a for loop. And so we'll disregard this answer. We know that this is not true. And then B says, yes, delete lines 4 and 10 and replace line 6 with the for loop. And so first of all, it seems like B, C, and D is all identical in saying delete lines 4 and 10. And so let's have a look at lines 4 and 10. And so line 4 basically increments or declares the variable of I as 1. And then line 10 basically increments the I by 1 every single time. And so we can kind of confirm true that we can delete lines 4 and 10 because both of these things is handled by the for loop, right? So when we use a for loop, first of all, I is already declared. We don't have to manually declare the I like in the while loop because I is already here and lives within the for loop. And then we don't have to increment the one I every single time because that's what a for loop does. It basically increments every iteration. Whether it increments or gives it the next value, that's what a for loop does. And the for loop handles that. So we can see that all B, C, and D is correct in saying that lines 4 and 10 should be deleted, right? And so this is good. Good start, right? We know the answer is within B, C, or D. Looking closer at the for loops for B, C, and D, the only difference seems like the second parameter for the range, um, which is n for D, n minus 1 for C, and n plus 1 for B. Um, and so first of all, before we kind of talk about the second parameter, let's look at the first parameter. The first parameter says it is starting from 1, which if we look at our code is actually a good thing, that I actually is initialized as 1 for when we're using the while loop. So we know that the range will go from 1 to some number, whether that's n plus 1 or n minus 1 or whatever. So first of all, we got kind of that out of the way, and we know that it starts at 1. So what we probably want to do is represent the second parameter as n, right? As reaching to n. Now we don't know if it's n plus 1, n minus 1, or n. We will figure that out. But we know since it starts at 1 and it increments every single time and it has to reach n, it's a good thing for our logic. And so it's good that it's starting from inclusive 1, right? And so in the for loop, as I've kind of mentioned before in the previous question and this question as well, ranges in Python, how they work is it's inclusive for the first parameter and then not inclusive for the second parameter. And so we got to figure out whether n for the while loop is n plus 1, n minus 1, or n, since this is non-inclusive. Now, let's try to think for the logic of this code. Do you think I will ever reach the value of n when it's iterating through the while loop? And the answer should be no, because the conditional inside the while loop is kind of like an if statement, right? And so if it doesn't meet this if statement, it will never iterate and skip to the next line. And this if statement within the while loop is saying if I is less than n. So if I actually becomes n, it will actually never run this inside code. And so this is actually non-inclusive n. And so I will never reach the value of n, which is very, very similar to D, how D works, because we know that this first value is inclusive and the second value is not inclusive. And this seems like it's identical with this while loop. And so as you can see, we know that C and B is not true because C would be not including the previous value of n, and then B would be not including the after value of n. So it will actually include n, which is not what we want. So D is the correct answer for this question. And let's actually check whether this is true or not. If we press D, submit, and we know that D is correct. And so that was question 6. Hi everyone, this is question 7 of Spring 2023 Exam 1. And this question is basically asking how do we convert line 8 into one of these answer choices? And more specifically, since line 8 is a ternary operator, how do we convert this ternary operator into just a regular if and else statement? Now, we covered ternary operators already in question, I think, 2, 3, and things like that, but I will just go over one more time very briefly so that you can remember. Basically, what it does is it will perform I and this operation, so it will add I to the sum if n modulo I is equal to 0. So if this conditional, it will take this and apply it here. Otherwise, it will take this and apply it right here. And so that's how ternary operators work. And so since we kind of reviewed this logic. So you'll add I to sum if n modulo I is equal to 0. Otherwise, you'll add 0 to sum. Let's have a look at the answer choices and see which one is correct. And so if we look at A, it's saying if n modulo I is equal to 0, so this conditional line is identical to this right here. So that's a thumbs up for now. It will assign sum equals to I. Now this down here is not the same with this code right here, right? So it doesn't pass the test. So immediately we can know that A is not true. It doesn't have the plus equals. Plus equals means sum equals sum plus I. So you'll just take the value of sum and then add I. But we know that A is not true. If we look at B, if n modulo I is equal to 0, so again, thumbs up on this. It's the same conditional right here. Sum plus equals I. So we know that this is true. Otherwise, sum plus equals 0, which also we know that this is true, right? And so we can actually just immediately say B is the correct answer, and we should be good to go. But we'll look at C and D and see why they might be wrong. And so the conditional is the same, which is thumbs up. However, for C, sum equals I. Now that is just assigning the value of I to sum, which is not what we want. So that is not true. And D is the same thing with C, but it's flipped, it seems like. So plus and equals is actually good on here, but it's 0 here. So, or it's equals here, not plus equals. So D is not true. So we can see that B is the right choice. And if we press it and then we submit it, boom. Okay, we got it right. And so that should be the correct choice. Yeah, so this was actually a popular answer, interestingly. And that might be because you might think that else 0 means just assigning it to 0, or it's just 0. But you have to always consider what is being done right here, right? This, again, is the conditional. And then this is either being assigned to this, or this is either being assigned and replacing the I. But this, the variable and the equal sign always stays the same. And so it's actually B, not D. But yeah, that's the question 7. Hi everyone, this is question 8 of Spring 2023 Exam 1. And this question is basically very similar to question 7 in that it's dealing with the same line, line 8. And then yeah, it's saying that S4 is saying that you don't need this else when you're converting the ternary operator into a regular if-else statement, because sum plus equals 0 actually is the same as not having an else statement, right? And so it's saying that you only need an if statement when you're converting the ternary operator to the regular if and else statement. And so it's saying which syntax is the correct one for converting line number 8. And so let's have a look at this question and the answer choices. And so A seems like if this conditional, and you can see that the conditional is the same, which is a thumbs up. Sum plus equals I, and so that is this part right here, and it is the same, which should be a thumbs up. And the else doesn't really exist. Now, that is different to the logic in here. However, this question is saying that 0 doesn't necessarily need to exist, because 0 plus equals sum, right, is the same as just not running any type of code. It's just leaving it alone. And so you don't necessarily need an else statement in the regular if statement form. And so as you can see, A is actually the correct choice here. And so that's actually the upside of just using an if statement other than a ternary operator. If the case is that when there's an else clause, nothing happens. So if the else does nothing, then it's actually nicer to have just a regular if statement than having a ternary operator, because ternary operators, you always have to express the else clause, right? And so that's the upside for just the regular if statement. And then let's have a look at why B is wrong. B just the sign is different, right? So it's not plus and equals, so that is wrong. C does the same thing, but it has two things wrong. So it's not equals equals, and also it's just normal equals instead of plus equals, right? So that is wrong. And then D gets this right, but it gets this wrong right here. And so that is wrong. And so A is the correct answer in this. That was a very simple question because we have kind of solved question 7. And so that was a pretty easy one. And so let's have a look if A is right. Got it. Most of y'all got A right, so that's a good sign. All right, nice. Hi everyone, this is question 9 of Spring 2023 Exam 1. And through this question, we have actually found out that, or at least I have found out that this function basically helps us determine whether a number is a prime number or not, which is quite interesting. And so how this function works is it inputs any value, and that is represented as n, any number. And basically, the sum over here is the number of numbers that can divide n without any remainders, with remainder 0. And so that is kind of reflected here, which is if n modulo I, and we talked about I in the previous questions, I is going to be from the range of 1 to everything right before n minus n, right before n, which is n minus 1. And so if n modulo I, which is going to be all numbers 1, 2, 3, 4, 5 reaching n, equals 0, which tells us that it has no remainders, then it will add I to the sum. And so that is basically the sum of all the i's that are divisible by n without any remainders. So that is what sum is going to be. Now, if you think about prime numbers, the only time this condition will hold true is when I is 1 or I is equal to n, right? But we know in this case that n is not inclusive, so it will never run when I is the value of n. So the only time when this condition will hold true is I is 1, and then that's why sum will be 1 for prime numbers, and when it's returned, it will return 1 for prime numbers, which we have found out from this question. And so that was kind of an interesting information. And this question is basically asking which of the following code snippets, so out of these 4 options, will print out the first 20 prime numbers. And so what we want to do is print out first 20 only prime numbers, 20 prime numbers, right? And so before we look at the code samples, we kind of have to understand what this code is doing, because this code will basically be replaced by these codes. And so what this code is basically doing is it's printing out the first 11 numbers, first 11 including 0, right? So it's doing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, not including 11, right? And so it is printing out the sum that we talked about earlier, the sum of the first 11 numbers, including 0, starting from 0. So it's 0, 1, 2, 3, 4, 5, 6. Is this 11? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, so it is the 11 including 0, not including at the index of 11. but it is including the sum that we talked about for the first 11 numbers. And so that is what the for is doing. It's printing the string for each of them, and then it's printing the number itself, which is I, and then it's printing the outcome, which is return sum of this function. And what we want is the first 20 prime numbers. So this is probably not good because this prints regardless if it's a prime number or not. As you can see, if it's a prime number, the second will be all ones, right? Because it has to be a return. This has to return the sum of 1, which we talked about earlier. If it's a prime number, it'll all be 1 on the right side. Sorry about that. And so this is no good because this is basically getting the first 11 numbers no matter if it's a prime number or not. And so with that in mind, we can actually jump to the answer choices. And so we'll have a look. And so will A print out the first 20 prime numbers? So let's have a look. So what count does is it is just 0. It's just declared as 0. And what it's doing, it seems like, is if the return value for this is equal to 1, which is a prime number, so that's thumbs up, right? It prints I, and then it increments. It increments the count by 1. Now, the question is this going to print the first 20 prime numbers? And the answer is unfortunately not. It is going to, just like this example, right? Just like this example, it's going to print out the first 21, including 0. Starting from 0, it's going to print out the first 21, but it's going to count how many are the prime numbers of the first 21 values, not printing out the first 20 prime numbers, right? That's what we want. So we know A is not true. It's no good. B, let's have a look. Oops, is a similar case in that it is printing out the first 20. So at least B meets the requirement of 20. At least the number is the same. First 20 of what it seems like, just first 20 of non-prime numbers. Again, just like A, yes, it is counting how many numbers are prime numbers within that first 20 numbers, but we have no guarantee that the first 20 numbers is going to be all prime numbers. And so B is not true either. Let's have a look at C. So C and D, interestingly, uses while loops, which might be much suited for this task. And so while count is lesser than 20. So C starts with count as 0, as always. On the top of the code, it all started as 0. And then I is first 1, right? And then while count is smaller than 20, if this is 1, which is a prime number, if it's a prime number, then it prints the prime number, and then it increments the counter by 1, and then it also increments I by 1. So this is pretty interesting because this seems like it's much more logically consistent than compared to A or B. It's saying that while count is less than 20, right? The while loop's going to keep on running, and it's going to call this function over and over again until there are actually 20 prime numbers. And so let's have a look at this, the difference between C and D. And so the difference between C and D is C uses count as the conditional for the while D uses the I for the conditional in the while loop. And if we kind of, as we talked about before, the answer is C, and we can know that straight away because as I talked about it and went through the code, while the count is less than 20, and count represents the number of prime numbers. So while the number of prime numbers hasn't reached 20 yet, it's going to keep repeating. But for D, while I is less than 20, and I is the same thing as the I for the for loop. So this is just identical to just using a for loop, because I increments regardless whether it meets this criteria or not. So I is just going to just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 20, regardless of whether it meets this conditional or not. So this is just going to print out the first 20 values, and count how many prime numbers there are. So we know that C is true, D is false, and we can check this out, and C should be correct. And there we go. And it seems like A was kind of the next most popular answer, and we've talked about the for loop isn't the best for this, especially when we're trying to basically function depending on the actual number of how many prime numbers are, not not the I variable. Hi everyone, this is question 10 of spring 2023, exam 1. And apparently this function just got cooler because this now accounts for perfect numbers. And so apparently this function also accounts for perfect numbers. If these two numbers are the same, it is considered as a perfect number, because if the input n is the same as the output sum, then it is considered a perfect number. An example is 6, because the divisors of 6 is 1, 2, and 3. And if you add 1, 2, and 3 together, it becomes 6. So that is very interesting. And this function, it makes it greater. So that's kind of nice to have. And then it says the first 5 perfect numbers are 6, 28, 496, 8,128, and 33,550,336. Wow. Okay. And so it's asking which of these following loops will print these 5 perfect numbers. I don't know why A is selected, but let's actually have a look at A first then. And so as we've seen from the last question, basically lines 14 and 15 are going to be replaced, and it's going to be one of these 4, just like question number 9, since this basically just prints the first 11 numbers starting from 0, first 11 numbers, and that is not going to be all perfect numbers. As you can see, it has to reach like 33 million. And so let's have a look at A. And so A is saying for I in range 1 from 1 to 33 million, if the function call is equal to 1, then it's going to print I. And so if we think about this, this is not going to be correct, because this would be a prime number that we took account of in the last question. This is not a perfect number, right? Because perfect number is when the input and the output is the same. So when you input 6 and the output is 6. And so it shouldn't be 1 here. So this is not correct as we see it. And so let's kind of have a look at B. And so B says for I in range 1 to 33 million. Actually, let's kind of take a step back and see the second parameter for the range. As you can probably notice, this is 1 more than the range. And so this will actually include this 33 million number, because this is one more than the range, or 1 more than this number, right? And we know that the range is not inclusive for the second parameter. So for B, we can see that it is not including, right? This is 7, this is 6, and this is 6. So this is going to be not included, which already throws us a red flag, but we'll have a look at its contents. So if we see if the function call and if the input I is equal to I, which is actually the right logic, because remember, if the input and the output is the same, then it is a perfect number. And so the logic for that is correct. However, it's just this initially that is not going to qualify this. And so this is no good, which is very unfortunate. We'll hop over to C. C, we see the same problem over here, which is not including. So we can kind of cross this one out without having a look at it. Briefly looking, it's also going to be accounting for the prime number, not the perfect number. So it's not going to be right. And then D, we already know that it's correct, but we have the I over here, so input and the output is the same. And when input and the output is the same, it's going to print it. And it's also including out 33,550,336. It's going to include a 36, but it is stated as 37 over here. And so we can test whether this is right, and we'll see. And indeed, this is correct. A good amount of people answered either A and B. For A, the wrong thing is the 1, and for the B, the wrong thing is the second parameter. And so it is D. Hi everyone, this is question 11 of Spring 2023 Exam 1. And this question basically asks, what is calling this going to return us if there's a list of these values and then there's a function right here. And this list seems like it's containing the names from the Assassin's Creed series, which is interesting. Whoever made this question, that's cool. And so let's have a look at what this function does. Okay. And so this function takes in a list, which is shown by the L right here. It takes in a list, and then it first sets the variable current max as the first value from the list. In our case, it's going to be alter. Alter, yeah, if that's how you say it. And then, so the current max is going to be the first value in the list. And then the length is going to be length of the list. And so it's going to be 1, 2, 3, 4, 5, 6, 7. So it's going to assign 7 to our length because there are 7 values within our list. And then there's going to be a for loop iterating through. So it starts at 1 and including 1. And then it stops at length, but not including length. And so not including actually works out for us because the length is 7, but our end index is actually 6, right? So it's not including the 7th index, which doesn't exist, but it is including the 6th index because it's 0, 1, 2, 3, 4, 5, 6. There are 7 values, but the index is 6th, so it actually works out in our favor, which is good. And then within the for loop, there is an if statement, which is counting, or which is setting the current max to the value at a particular index if that value at the particular index is greater than the current max. So what this code does is first it sets the max value as this, and then it basically starts from here and then runs through each value, comparing whether the current max is smaller than this value, this value, this value, this value, this value, this value. And then as it's running through the for loop, the current max will update going on, right? And so that is what the code does. Now, an important question to ask in this question is, what does greater mean? Because we're comparing two strings here, right? Current max is the first value in this list, and then list I is whatever value whatever value in the list at that particular index. If I is 1, it will be this. If I is 2, it will be this. 3, 4, 5, 6, right? And so how do we compare this string with this string and determine whether one is bigger or not? Now, something that you might immediately jump to is this has more letters, so it's going to be bigger than this, right? But unfortunately, if it would be really nice if it was that intuitive, but unfortunately, that is not the case. And computers have to make it complicated for us once again. And so the greater sign when you're comparing the two strings is determined by what is called lexicographical order. And what that means is basically it sees the first character within a string and determines by dictionary, right? If you think of like not like a Python dictionary, like a regular dictionary, it basically orders these, and it is basically seeing whether A is um, is earlier in the alphabet than E. If A is earlier in the alphabet than E, is if S is in the earlier alphabet than A. So basically, A, the first letter, is smaller than E in this case because E is further in the alphabet than A. That is what lexicographical ordering does. It is basically coming from the ASCII values, which basically um, assigns a character with a number. It differs by hex values or decimal values, but that is something that you guys don't have to worry about. But it is basically A basically gets a lower number than E because it is earlier in the alphabet. And so if we have a look at this list, we can see that the the name with the biggest number will probably be not A. We have bunch of E's, and then we have S. And so this will be indeed our answer because in the alphabet, S is the most further down. Now, let's say that shall didn't exist, right? And so, like I said, lexicographical ordering basically looks at the first letter for each of these strings and then compares it, right? However, we can see that there are a bunch of E's and A's, and so the next biggest one will probably be one of the E ones because the S is gone and we're not considering it just for fun sakes. But it will be one of these three, right? And so how do we determine which one is the biggest? Lexicographical ordering says look at the next letter. And so it looked at the first letter, it's identical. And then it looks at the next letter, and so the next largest will be this right here because it has a value of Z. But for our question, since it was a pretty straightforward answer, we have shall as our answer, which is B. And so we will check this and see if I'm right. And let's have a look. Sorry. And in our case, B is correct. And most of you guys answered C, which is completely understandable because it has the longest. It's the longest string, right? But unfortunately, that is not how it works. And yeah, sorry about that. Hey everyone, this is question 12 of Spring 2023 Exam 1. And this question basically asks what line 3 does in this code. And so what will the current max variable hold after it executes line 3, which is list and this bracket notation and 0 inside it. And so as we could recall from question 11, the input for let's go back to question 12. The input for the the function is this list, and then you basically call the function with a list inside of it. And then basically L gets assigned to the variable of list, and then it's asking what is line 3 doing, which I think this is a pretty straightforward question. If you ever see this bracket and a number inside of it in a already declared variable, it's saying at that index, what is the value? For lists, it's saying this is index 0, 1, 2, 3, 4, 5, 6. And so it will, of course, assign this value to the current max. And so if we have a look at the answer choices, the value of current max after running line 3 is 0, since the first index of a list is 1. We know that is not true. The entire architecture of computer uses 0 instead of 1 as the first index. B says a special value for Python to indicate we just accessed a list. I don't know what that is referring to even. And then C is the item at index of a given list. We know this is true. The minimum value of a list is not true. That's not what the 0 does. We'll check the answer now. It's probably C, and most of people got it. A few of you guys answered B, which is a special value for Python to indicate we just accessed a list, which is not going to be the correct answer. And basically, if you see list and this bracket notation, it's basically trying to get whatever value of the list in that index. Now this works with strings too. So if we had a string called hello, and we basically assign it to a variable called, let's just say S for string. Now if we called S brackets 0, right? S brackets 0, it would actually return this value right here. It actually works pretty interesting in string. It works both in string and a list. In lists, it's basically doing 0, 1, 2, 3 with instead of looking at each of the characters within the string, it's separated by the comma. But within strings, it is 0, 1, 2, 3, 4. That's just something nice to know. You guys probably knew this, but yeah, the answer is C. Hi everyone, this is question 13 of Spring 2023 Exam 1. And this question is asking, what does line 4 do in this code? Last question it asked, what does line 3 do? This time it is asking, what does line 4 do? And so basically what this len function does is it takes the length of either a list or a string. And if it's in the case of a list, it counts how many values are in that list. But if you input a string here, then it basically outputs how many characters are in that string. And so this is a pretty straightforward question, just like the last one. It's just a syntax question, right? So the function len in line 4 returns the number of items in the list. We know this is immediately true. The sum of the sizes of the items in the list. So that is not true. We don't even know what the sizes necessarily mean. If we say we are summing the sizes of all the strings in the list, it is not true. It's just how many items that are in the list. So B is not true. C says the length of the largest item in the list. This is not true. To do that, you would actually have to use something like a max function instead of a len, and then input it right there, like that, right? And then the length of the smallest item, which would be min. for minimum. So the answer is A. Let's see. Yay. All right, good job, everybody. Hey, everybody, this is question 14 of Spring 2023 Exam 1. And the question asks, to modify the function to return the minimum item in the list, we must, right? So we know that this is a function that returns the maximum value from a list. And so um, by maximum, it is determining what is the largest by lexicographical ordering. We went over this in question 11. And so in our case, shall was the largest because S is the largest in the ASCII world. It's above A and E just because A gets the earlier ASCII value than S, but no need to go into too much detail for that. And so this question is asking, instead of max, how do we make it a min? And so um, looking at this question and looking at the logic of this question is important. And so to make it a min, what do we have to change in this code? And the only thing you probably have to change is this sign right here. And all you have to do is convert the sign the other way around, because what this code is doing is basically it is iterating through, it is first assigning this value as the current max, which is this, the first value, and then it's iterating through the list and it is checking if the current item or the iterating item is greater than the current max. Now, if we flip the signs, it's checking whether the current max is bigger than list the iterating list item. And so if we look at here, then the current max is not bigger, so current max will stay the same, right? And then the current item is still not bigger, and then it will iterate through all of them, but this is the smallest item, and so it will stay the same. And so you just got to flip these signs right here. Let's look at the answer choices. And let's have a look. Change the value of current max in line 3 to some large initial value. Not true. The only reason why this is initialized as the first list value is because we're running from 1 to the end of the array. So you don't have to compare the same thing twice. That's the only reason why. Change the value of current max in line 3 to some small initial value. This has nothing to do with returning a minimum item in the list. Change the comparison operator in line 8 to the other way around. So it's this way, right? And we looked at that and it was true. And then D says not possible, which is, it is possible. So let's have a look at the answer. Boom. Good job. All right. Hey everyone, this is question 15 of Spring 2023 Exam 1. And we are asked, how do we modify this function so that it counts the number of items equal to the first item on the list? So it's asking, how do we count the number of items within the list that are equal to the first element? And we want to count that. And so this question is pretty similar to question in 13 and 14, which was larger or smaller, but this time it is equals. And so let's have a look at the question. And so let's kind of step back for a bit instead of just going straight into the answer choices. And let's kind of think what changes we have to make in the function in order to make this work. So first step is probably we make this some sort of an equal sign instead of a larger or a smaller, because in question in 13 and 14, this was kind of like something that we have to change. And so it's probably a good idea to change it to equals equals so that it checks whether the item in the iterating item is equal to the current max item. And so what what also probably needs to happen is we probably need to count how many items are equal to that. And so now we probably want something like a count variable, which I'm going to declare here. And we probably want to set it to something like 0. And so let's have a look and let's kind of, in our mind, run this code. And so first of all, alter is the current max, and then the length is going to be 7, and then count is going to be 0. So we now have this new count variable, which is good. And then for I in range, including 1 and not including the length, which is 7, if list I, which is the iterating item, so it's going to be starting from here. If this is equal to alter, then current max becomes the item. So as you could probably see, this is not what we want because this is basically going to replace this, replace the current max. And the question asks, how many items are in the list are equal to the first item? So all we need to care about is the first item, right? So we probably don't want this line of code replacing the current max. And so let's kind of comment that out. Well, this is not what we want. Let's actually delete it. And then the requirement for this question was count it. So instead of replacing it, what we want to do is increment count by 1, right? And so this is probably what we want to do. To make things less confusing, we don't really need the current max variable, and we could just probably make this a first item, right? So is the iterating item same as the first item? Then increment the count by 1, right? And so this is the changes that we got to make. We have one more change left, which is returning. The current max doesn't really exist anymore. So let's return count. And so this is probably the code that you want in order to meet the requirements for this question. And so let's have a look at the answer choices and see what it's saying. So it's saying change the value of current max in line 3 to some large initial value. And so I'll kind of return everything in the code so that count max is back. So this was the initial code, right? And answer A is saying change the value of current max in line 3 to some large initial value. That has nothing to do with the first item in the list. And this will not even consider the first item in the list. So we know that that is not true. That is not what we want. B says change the value of current max in line 3 to some small initial value. Again, this is not at all useful in what we're trying to accomplish because it will just set the current max to a value that is not the item 1, and we want item 1 to be considered. Change the comparison operator in line 8 to equals equals. Now, that was the first step that we took, right? The first step was equals equals, but we saw that current max gets reset every single time, and what we want is probably this, right? What we wanted was this, where we have a count variable, where we increment the count, where we not update the current max value, so we can keep the current max value, but we didn't want this line specifically, right? We didn't want this line. And so just changing this never ended working for us. So C actually is a closer answer than A and B, but it is still not true. And then the most accurate answer is none of these changes alone is enough to make the function to count the equal items. And that is true because we saw how many steps that we had to take in order to count the number of items that are equal to the first item. And so D will be the correct choice in this. And if we have a look, D is the correct answer. Unfortunately, a lot of you guys answered C, but like I've just walked through, C alone, just this difference cannot alone count how many items that are equal to. All this does is basically, if it is equal to, then it will just assign current max as the same thing that is equal to. It will not count how many times that thing appeared in the array. It will just return the same thing. And so that is the reasoning for that. But yeah, good job.